Okay, now you are ready to start building the module-based rigging system using non-deformed bounds. Now we're going to be taking a universal approach to doing this. So what this simply means is that when you come across different rigging systems, they will seem familiar to you, meaning that you will understand how they all work internally. Now the first thing that I want you to do is go ahead and click on the armature and switch to edit mode. Then press the 3 key to go to your right view and go ahead and select the root bound. Let's go to the bone tab. Now over here, what we need to make sure that this is unchecked. This simply means that this is now a non-deformed bone. So any new bones that we create now, we always have to make sure that this is unchecked. Now, if you forget to uncheck this, and let's say you import this into the Unity game engine, you will simply get a warning message, and what Unity will do is simply look at any bones that are checked with deform, and if they do not have vertices assigned to them, Unity will just take some vertices from your figure and assign them to these bones with a weight value of 0. Right, so that's something you don't want to happen. So just make sure that any new bones, this is always unchecked. Now, the other thing here is that if you go to this data tab, you can see that right now all the bones are on this layer. So when we create the non-deformed bones, we're going to put them on this layer. But for this root bone, we're simply going to put it over here. It's just a good idea to separate these ideas into layers. So what I want you to do is, having this root bone selected, just press the M key and simply select this layer. Now you will notice that you actually have to move your mouse over this to refresh this, okay? So now when we click on this, this is the root bone, and if we click on this, these are all our deformed bones, okay? So you can of course press the shift key down and click on this layer to enable it. So now what we're going to do is go ahead and zoom in, do shift middle mouse button, and focus in on the head and neck area. We're going to build the head and neck rig first. So what I want you to do is click on the head bone, press the shift key down, click on this neck bone, and do shift D to duplicate. And now right click to cancel the movement. Now you want to press the control key down, then click on this green arrow and take it to the right. 1, 2, 3, 4. Now we're going to put these bones back in the same exact position. This is why we use the control key to snap to the 3D grid, because it's going to be important to make sure that they go back in their original position. Okay? So now what I want you to do is to go ahead and switch to pose mode. So what we're going to do is simply tell the deformed bones to copy the location, scale, and rotation values of these key bones. Okay, so basically there really is no relationship between the deformed and these non-deformed bones. We're only going to move the deformed bones or drive the deformed bones with constraints. So this is how a module-based system works. What this simply means is that you are never going to involve the deformed bones directly with these module-based systems, meaning with parent-child relationships, okay? So what this gives you is the ability to delete out these module-based systems. So what I want you to do is select this bone, press the shift key down, select on this one, and press the M key. And here we're going to move this bone to this layer. Again, you have to hover your mouse to refresh this. Now press the shift key down and turn this layer on, right? So now when you're working with module-based systems, all you have to do is click on this layer and switch to edit mode and select everything, do X, and delete all your bones, right? So you can wipe out your module-based system without hurting the original setup of the deformed bones. This is how this concept is going to work. It's basically a very clean approach to creating a rigging system. Anyways, go ahead and press the shift key down and go ahead and enable this layer. We don't have to look at the root bone right now. So now go ahead and switch to pose mode. Click on this bone, press the shift key down, click on this one, and here we're going to do shift control C and do copy transforms, meaning that we want the location, rotation, and scale of this bone. Right, so it's going to become green. So go ahead and do the same thing for this neck bone. Click on this bone, press the shift key down, click on this one, do shift control C, and now do copy transforms. So what exactly does this do for us? This allows us to now click on this non-deformed bone and press the R key and rotate. Right, so whatever these non-deformed bones do, the deformed bones will simply follow them. That's the idea behind this. So now go ahead and click on this bone, press the shift key down, click on this one, and of course switch to edit mode. Now press the control key down, click on this green arrow, and take it to the left, 1, 2, 3, and then 4. Now all we have to do is just click on this layer, and we can start setting up the module-based system. So of course we have to make sure that these are non-deformed bones, so go ahead and click on this head bone. Go to the bone tab and uncheck this, click on this one and uncheck this. Now you'll notice that when we duplicate bones, we are also getting the parent-child relationships, right? So they are directly involved with the deformed bone. So this is something we do not want. So go ahead and press the Y key to sever all the connections. Click on this one, press the Y key to sever all the connections, okay? Because we're going to set up our own unique parent-child relationships. Now over here, what I want you to do is go ahead and press the control key down and middle mouse button and just scroll up to zoom in over here so we can look at the name of the bones a bit clearly. Remember, to reset the zoom, you simply have to press the home key on your keyboard or press the special FN key and the home button if you are on a laptop to reset the zoom. So now we need to name these bones, right? So before, when these were deformed bones, we used the dev prefix. So the naming conventions are going to become pretty important so you can understand how your module-based system works. So now, since all of these new bones are going to be non-deformed bones, meaning mechanical bones, we're going to simply click over here and type m dot head dot flex dot c and enter. Now this is just a naming convention. It means it doesn't have a special meaning in Blender like the .L and the .R, okay? So M basically means that this is going to be a mechanical bone, meaning that it's going to be driven by other bones and the user will never touch this bone. And this is just a head bone, and here I've just added the word flex and .C. .C means that this is going to be a child of another bone, okay? So we're going to do the same thing for this bone. Go ahead and click this and type in M dot neck dot flex dot C and enter. Okay, so that's the first step. Now over here I want you to switch to pose mode. Now you will notice that because we've removed the parent-child relationship, if you press the R key here, we can rotate, and the head of course is going to start to move, is because the deformed bones are simply going to follow whatever these bones do. Okay, so this is what we want. So go ahead and switch to edit mode. Now what I'm going to show you is going to become very important when you're dealing with parent-child relationships and creating module-based systems. It's going to come down to the parent-child relationships and taking advantage of the alignment of bones. So what I want you to do is click on the head of this bone. Now if you click again, it'll select the tail of the neck. So if you click again, it'll select the head. It really doesn't matter how you do this. Just press the E key to extrude, and over here you need to press the Y key. Now this is going to become very important a bit later. We need to make sure that these bones over here are going to be aligned to the y-axis. They have to be perfectly aligned like this. So go ahead and just park this bone, okay? Now go ahead and click this and make sure that the deform is off. And over here, we're going to call this m.head.flex.p, because this is going to become the parent of the other bound. Okay, that's all this means. So go ahead and do the same thing on this one. Press the E key, press the Y key, and go ahead and put this bone over here. Okay, go ahead and click this, make sure that the deform is off. Do the same thing, just add a P over here. Now what we want to do is make this the child of this bone and make this the child of this bone. So go ahead and click on this bone, press the shift key down, click on this one, do Control P, and make sure that you do keep offset, right? So if you do connect it, it will simply take the head of this bone and connect it to the tail of its parent. So go ahead and click on this one, press the shift key down, click on this one, do Control P, and do keep offset. Now here you're going to see really the true power of parent-child relationships as we develop this module further. So what I want you to do is first go ahead and switch to pose mode. So here you'll see that when we click on the parent and press the R key, here it's going to take the child with it, which is this bone, right? Same way over here, if you click on the parent and press the R key, it's taking the child with it. Okay, so over here you can see that when we press the R key and when this bone moves, this module is not moving with it. So we're going to fix that. We're going to do Alt R to reset the rotation. So all you have to do over here is click on this, press the shift key down, click on this bone, do Shift Control C, and here we're going to do copy location. Now of course this is going to go down because you've seen how this works. When you add a copy location, it of course will always go to the head of the bone. So here we're just going to say that go to the tail of this bone. Now watch what happens when we use this technique. Now when we click over here and press the R key to rotate, notice that the head stays perfectly still. Okay, so this is just the beginning stage of understanding the power of using parent-child relationships. Okay, so we get that solved. So what does this mean now? This means that we don't have to actually mess around with this bone, right? Because we can use this bone. So here, having this bone selected, we can simply just lock them all up, right? Because we don't want the users to touch this bone. Now later, we're going to lock these bones too, but this is not the right time to do it. Go ahead and click on this and go ahead and now lock it. Okay, so this should make sense to you as to how it's working. Now we're going to go ahead and make this a bit more advanced. Okay, so what I want you to do is go ahead and now switch to edit mode. Go ahead and click over here on this joint and now press the E key and just put a bone out like this. Now this bone is really going to be the bone that the user is going to click on. Now we're going to give it a bone shape and it's actually going to appear over here. Right now we're just going to leave it like this, and this is simply going to be the touch bone that's going to drive the head and neck bone. Okay, so what I want you to do is, having the body selected, press the Y key to sever all the parent-child relationships. Of course, go to the bone tab and uncheck this over here, and here we're going to call this head.touch. Okay, now notice that we didn't use the letter M because this is not a mechanical bone, meaning that we want the user to work with this bone. This is why we use this naming convention. Okay, so now what we're going to do is really use parent-child relationships again. So here what I want you to do is go ahead and click on this joint again and press the E key and now press the Y key. Now you're going to make sure that this bone is aligned. You can just put this bone over here. Okay, so you can see that we're now starting to overlap bones. What this simply means is that we will have to go to the Object tab and we have to switch this to Wire. So now when we create the module-based system, everything is going to be done in wireframe. So here you can see that when we are aligning these bones like this, right, we're simply going to be burying bones inside them. That's all this means. Now always keep this in mind that when you align these bones like this, you can always click on the tail and move this bone over here to make room for other bones, right? And later you can move these and tighten them up. But what's important here is that the alignment stays like this, meaning that these bones over here must be perfectly horizontal, because we're going to use these alignments to our advantage. Notice that this is horizontal, and this is horizontal, okay? So anyways, go ahead and click on this bone, press the Y key to sever all the connections, go to the bone tab and uncheck this. Now let's go ahead and name this bone. So here this is going to be a mechanical bone. So we're going to say that this is going to be M dot head dot touch dot tracker. Okay, now that's a pretty big name. Now the reason we did this is because this bone is going to be the child of this bone. Okay, notice that this bone is the child of this bone, but here we're going to flip the relationship concept. Okay, so we're going to click on this bone first, press the shift key down, click on this bone, do Control P and do keep offset. Okay, so now when you switch to pose mode and click on the head dot touch and press the R key, you will notice that of course the child is going to follow its parent, right? It's going to come down to this bone. So what exactly does this do for us? This means that what we can do is simply tell this bone to copy the rotation of this bone. Okay, this gives us the ability to click on this bone and rotate this head. So go ahead and click on this bone, press the shift key down, click on this one, do shift control C, and over here we're going to do copy transforms. Now when you do this, it's of course going to go down. Now remember, because we selected that bone as the last bone, we're actually seeing the properties over here. So if you go to the constraints, you can see over here that first we copied the location values of the neck, then we told it to put itself on the tail, and over here, because of the order of execution, here we're simply overriding with the copy transforms the location value. So to fix this, all we have to do is put this up, right? So here, when we get the copy transforms from this bone, here later we're coming in here and saying that we're going to overwrite the location value. So what this simply means, it ports itself over here. Okay, so now when you click this and press the R key, you will notice that this gives us the ability to rotate the head. Now take a look at what's going on. If we press the R key, okay, notice that this bone is perfectly aligned with this bone. Okay, so now if you click over here and turn off location, you can actually see the proof of this. Both of these bones are aligned. Okay, so here we're using parent-child relationships and taking advantage of the alignment to create this module system. So go ahead and click on this bone, do Alt-R to reset the rotation. Now of course when you press the R key, here we're simply rotating the head, right? So here we can also tell the neck to rotate just a little bit by simply doing the same thing. Click over here, press the shift key down, click on this one, do shift control C and do copy transforms. So now when you click over here and press the R key, we're moving both the head and neck, right? Now we don't want the neck to move all the way, so here we can simply click and type in 0.5 and enter. We just want half the values. So now when you click on this and press the R key, you will notice that it gives us natural movements when we move the head, because it's moving the neck a little bit. Okay, so that's the first concept I want you to understand about this process. So now go under File, do Save As, and we're going to save this as rigging lesson 3b.blend. So I'll see you in the next lesson. Thank you.